My name's Callum. I'm a JS senior consultant here at IO. So IO is a specialist tech and engineering recruitment agency. So this is our third JS meetup. We're really excited. We're looking to build a community, and hopefully, moving forward, we'll have more and more people joining, and a variety of different speakers as well. In with myself is Fraser. He's also a senior JS consultant. So myself and Fraser just do permanent hires, and then Caitlin is our JS contract consultant, also a senior consultant here. But yeah, without further ado, here's our barcodes if you want to look us up on LinkedIn, if you want to reach out to us afterwards. But it's not about us, it's about Rob. So again, thanks Rob for speaking today. I will unshare our ends and let you take over. So yeah, over to you.
Yeah, hi guys. Thanks for joining this evening. Like Callum says, I'm Rob. I'll start sharing my screen. Right, I'll have to double check if everyone can see my presentation.
I can see it fine.
Yeah, okay. I've got two screens and I don't know how it plays with Zoom, but I'll go for it. So the challenges of dynamic content in a static world. So we all have a dream of making websites as fast as possible. And to do that in today's world, you have to try and make them as static as possible, because hitting servers are slow, basically. Too slow for today's world. They want things to be static, fast, and straight on people's mobile phones. But there are challenges that come with that, because we can't always be static. We need to have dynamic content as well. So my background, I've been web developing for, I don't know, 18 years. It keeps growing up. I always say like 15, and then I realize it's actually 18. Worked in publishing quite a lot. I had a long stint at Bauer Media, which is one of the largest media publishers in Europe. Went to Social Chain, which is the company that was owned by Stephen Bartlett, you know him from Dragon's Den. And now I've ended up at Dexerto. So Dexerto is the world's largest eSports and influencer media group. So we have our main website, Dexerto.com, which gets about 60 million users every month, about 70 or 80 million page views. We have millions and millions of social media followers across like TikTok and Instagram and Facebook and so on. We basically just deliver esports, gaming and entertainment news 24/7 around the world. Our biggest audience is in the US. And talking about our tech stack, we use Next.js on the front end, which is obviously a framework built on React. Node.js for a few bespoke backends that we do. I've noticed that our tech lead backend developers joined us, so big shout out to him. And a GraphQL endpoint. I love GraphQL because it makes the amount of data that you're transferring minimal and just what you need to get. So I mentioned a bit about this. We use Next.js frontend and WordPress backend. Some people might be like, why are you still using WordPress? But from an editorial point of view, it's a very familiar platform that people use day to day. Like we'll have new editors come and join the team, and it's pretty much guaranteed that they've always used WordPress. So they can just jump on and on board pretty quickly. And using Apollo Server, you can turn that WordPress backend into a GraphQL API. So what's coming up? What am I going to be talking about? The challenges of dynamic content in a static world. So as I mentioned, we want everything to be static, but we also need things to be dynamic. So how do you get that fine balance between the two? Do a quick introduction about static site generators in Next.js. I'm not sure of the level of knowledge that people have around static site generators, so we'll just do a brief introduction of them, just going over their benefits and how they can handle dynamic content. Then we'll go into in-depth strategies of how we can manage continuously changing content in the static world. And then we'll touch on performant A/B testing, because again, A/B testing introduces that area of dynamic content to the website, and it's a bit tricky when you're working with static content. So, overview of static site generators in Next.js. So the basic premise of static site generators is that they build the static HTML files on build time. So there's no going to a server to fetch the content, to then generate the content, to generate the page. This static HTML file already exists. Some of the popular static site generators at the moment are Jekyll, Hugo, Gatsby, and Next.js. And static site generators have tons and tons of benefits. The main one being performance, like loading a static HTML file is tons faster than hitting that server, going to the database, bringing that content back, building up the page, and then serving that out. Also, you can host these static HTML files across the world on CDNs, so you're getting closer to that user that you need to deliver that content to. Security as well, because there's no hitting that server when you're viewing these HTML pages, there's less chance that people are going to be able to hack into your website or run various DDoS attacks and things. And static site generators have been used on lots of various different websites. A lot of the time they're used on blogs and publishing websites, but they can be used in e-commerce, Wikipedia websites, anything really. So we use Next.js at Dexerto. One of the reasons, because it's the biggest out there. It's got a huge community of people that are working on Next.js. There's always someone that can help you find and solve problems. It's built on React, like I said, and it offers several features of fetching the content and displaying content. So for example, server-side rendering, SSR. So this is the first content that we'll talk about. This is when the data fetching is all done on the server side. By the server side, I don't mean the backend server. I mean the backend of Next.js that's running on a Node.js server. So the data will be fetched, the page will be generated, and the page gets displayed. So this is pretty much turning the static site generator into a traditional dynamic website. Client-side rendering. This is when we display the page without no content to the front-end user and then fetch the content. The content's done basically on the client side. Static site generation. So this is what I mentioned previously. This is where all the HTML pages that you need get generated on build time. And all the content's already done in that HTML page, and these HTML pages get served super fast. And then Next.js offers a slightly different rendering method called incremental static regeneration. So the Next.js team realized that a lot of websites have a lot of content, like the Dexerto website has about 80,000 pages. It'd be impossible to build them on build time. So we need this rendering method called incremental static regeneration. So we build up about 100 or 200 pages on build. They'll be the most viewed pages. So we know every time we do a new build of the website, these 100 or 200 pages are instantly available to our audience. The rest we generate on runtime. So whenever somebody hits that URL for the first time, everything is rendered on the server. So all the page content is pulled down from the API, and this HTML page gets generated and built and saved in the cache. We set a revalidation time of so long, and then when that revalidation time expires, to say it's 2 minutes, when that 2 minutes is up, the server-side generation of that page will happen again. So new page content will pull down and this page will get regenerated. And just as long as you don't rebuild the website, these pages will constantly keep doing that. So that was a brief introduction to static site generators and how Next.js handles rendering this content in various different ways. So the problem that we have is that we say we want a static site, but static sites aren't always static. We have 100+ editors writing content, writing new content, updating content continuously, 24 hours a day, 7 days a week. So we wouldn't be able to build a new website every time somebody does a spelling mistake and they need to republish a post. Like I mentioned, we have 80,000+ posts, and they could be constantly changing all the time. We also need an instant content update time. So for us, getting that content out to the world or updating content to new news releases or press releases or whatever is key. We need to be the first to have that news article out. We need to beat the other publishers. So we need to be able to create these pages instantly. And what happens if we have multiple posts per page? We have a most popular posts section on the website on each page. We have a related article. What happens when that post gets updated? Do we need to change the page that it's on, or can we just change that one section of the post without interfering with the entire post? So you can see our website isn't actually that static when you consider all these points. A possible solution: we could just turn every single page into server-side rendering. The advantages: the content is pulled down on every single page load, so the content's always going to be fresh. The disadvantages: that kind of gets rid of the whole point of these static site generators, and there'd be a massive server load, both on the back end of the Next.js application and also on the back end where the GraphQL API is run, in our case in WordPress. And we want to kind of try and keep our hosting costs as low as possible. So we want back-end requests to be as low as possible. And longer page load times as well. Because the data is being fetched on every single page load, it adds a second or two while it's pulling down this data. And a second or two in our world is way too much. We need that page to load as fast as possible because it'll help us get to the top of Google. Another solution: client-side rendering. So the content is always fresh because we're pulling the data down on every page load, but this time on the client side. So we actually have the page there, and then the content gets pulled down afterwards. So the page will load and then the content pulls down. Disadvantages: we still have that request going to the back end every single time on every single page load, so it'd be enormous. And the content won't be readable by bots. So client-side JavaScript rendered content can't be read by Googlebot. Googlebot likes to read server-side rendered content. It needs to be in the source of the HTML. And static site generation. So this is nearly ticking all the boxes that we need. The advantages: pages load fast. They're HTML pages, so they'll load really, really quick. Content is always fresh, so we can have every single page will have new content on build. But the disadvantages: every time somebody updated the post or created new content, they'd have to rebuild the entire website. And with 80,000 posts, that would take way too long. It'd take 10 minutes plus. And this is what I mean by too many frequent updates. So we just wouldn't be able to rebuild the website every single time. This is what incremental static regeneration solves. And this is the closest to exactly what we need. Advantages: page load fast, build time is short. We don't have to build every single post when content's updated or there's new content. We only build 100 posts on the initial build. But the disadvantages, because we need fresh content, the revalidation time of these posts needs to be super, super low. So you may as well just not bother with ISR because these revalidation times are like really, really low. So Next.js came up with a solution called on-demand revalidation. So on-demand revalidation is when we can specify which page we want to revalidate on the website. Say we update a post called Hello World. The on-demand revalidation will send an API call out to the next app, and we'll be able to revalidate just that single page. So page load is fast. We've still got the static HTML pages. Build time is short. We're not building every single post on build time. And content can be revalidated on demand. So we can send that revalidation request just to that specific post on the website. But the disadvantages, we still have the issue of client-side data. So we have an infinitely loading article page. When a user scrolls to the bottom of the page, another article will load. So we need to fetch data on the client side. So we still need to think about those API calls, and potential to revalidate too much as well. So we have all our posts listed on various category pages, on the home page, in tag pages, in author pages. So if we updated a post title, we'd have to revalidate every single one of those pages. We'd have to revalidate the home page. We'd have to revalidate every single category page that post is in. And we could be talking about pages 1 to 200 of this single category. So there's potential to revalidate too much. So that kind of doesn't solve our problem altogether. So our solution, we recently launched this a couple of months ago. It's called network caching, and it solved all our problems. So network caching, what is it? Network caching is used so resources aren't requested from the origin server. So instead of a user requesting a resource from the origin server, the request will first go to the caching layer. The caching layer could be a CDN, like Cloudflare or Fastly. It could be in the user's browser. So images get stored in user's browser cache, for example, or it could be in a cache layer on the actual server itself, like Varnish. And you can also cache API calls as well. And this is what we did to achieve really high performance and really good flexibility on content being updated. As you can see there in the image, working in a CDN as well is pretty good to improve response times, because you can get CDNs all around the world, and the request will go to the closest CDN point. So the first thing we had to do was move our post requests to GET. So post and GET requests are specific types of HTTP request method. So typically GraphQL requests include a query inside the body, and they use the post request. You can see in the image here that I've got an example body on the left and an example response on the right. And inside that body, it includes the GraphQL query. So in this example in the image, I've got a query for fetching a user, the user's name and ID with ID of number 1. The endpoint for this GraphQL request would just be domain.com/GraphQL. So how would a cache know what resource to return? We wouldn't be able to tell the cache whether we wanted a user, whether we wanted a post, whether we wanted category data. It just wouldn't know, because most caches in CDNs don't look into the body of the actual request itself. So the solution for that is just to switch the request to a GET. In GET requests, the parameters go inside the URL. So you can see there, the endpoint would be /GraphQL question mark query, and then the query. This way, all the queries that we run now are individually identifiable. So we know that this query, this request, is requesting posts with an ID, a title, content, date, and an excerpt. And we can now cache this specific request. And we can do the same for hundreds and hundreds of different API endpoint requests. So doing the get request method, you might end up with 2 long parameters. Like if you had a really, really big query, you'd end up with a massive, massive URL. Most hosting providers don't let you do really, really long URLs. So if you want to look how to solve that, just have a look into Apollo client persisted queries. We won't go too much into that, but it's a solution of how you can not end up with having 2 long URLs. So the improvement we first saw instantly was that the hits to our origin server reduced dramatically. Like we went from about 2,500 requests every minute down to 1,500 requests, and that made the server load ease up quite a lot. It can also reduce our hosting costs because we can reduce the spec down of that server. And because we're caching now, we can set a revalidation time on that specific cache. You can see in the image here that we have an X cacheable HTML header of short. That just means we're caching this API endpoint for 60 seconds. And these API endpoint requests can be stored in CDNs as well. So that also improves the response time, because instead of going to the origin server, we're going to these CDN points around the world. So somebody in Australia will hit the endpoint cache in Australia. So I remember thinking, isn't this just the same as ISR, like incremental static regeneration, revalidation, creates a page for 60 seconds and then refreshes the data. But what we wanted to try and avoid was revalidating too much in our cache. Some posts on our website have been there for 2 years and don't ever get updated. We just don't want to revalidate them at all because the content's not changing on that page. So we need a way to revalidate the cached API responses on new and updated content. So we could just use the API endpoint path like on-demand ISR. So we could just look for the exact endpoint and revalidate that. But the problem with that is that we don't know what data that endpoint has in. And that would, again, go to too much revalidation. And that equals unwanted origin requests. So we still want to reduce these responses going to the backend server. So to solve that, we can use header keys. Header keys. What are header keys? So on every API request, we add an additional header to the HTML response. You can see in the image here that we have X GraphQL keys. And in that header, we have various tags. So we've tagged the post ID, we've tagged the category, we've tagged whatever piece of data is in this response, this API response. So we know that when that specific piece of content gets updated, we have to revalidate every single API cache request that has this tag in the GraphQL keys. And that allows us to really, really pinpoint exactly which pieces of cache data we need to revalidate. And that reduces backend request loads. And we probably halved again the number of requests going to our backend. So I'm just taking a drink. So success. We've got an API endpoint cached in the CDN. You can see the image that the first request at the top there, the 1.2 kilobyte ones, was going to our backend server. This is actually a staging server, not a production server, so we wasn't getting many requests yet anyway. But it still took 530 milliseconds to get back to me. When this API endpoint was in the cache, we reduced that response time to 123 milliseconds. And that's an incredible reduction in response time. So we've got low backend server requests. Great. We can reduce the cost of our hosting provider. We've got less chance of things going into a bottleneck. We have low revalidation. We can be extremely specific on which endpoints we want to revalidate. If post hello world gets updated, we can go, okay, that post is in the homepage. We need to revalidate the homepage. That post is on page 2 of this category. We need to revalidate that. Instead of going, we need to revalidate the entire category pages. We need to revalidate the homepage on every post update. And we also get instant content updates, because this happens instantly when somebody presses the update button in WordPress or they publish a new post. This cache revalidation happens and updates the content. And it also works with client-side data too, because we use these exact same cached API endpoints in our client-side data fetching methods. We can revalidate these as well and keep them cached. I don't know if there's any, I don't know if can we do questions? I don't want to keep rambling on, but I can't see chats or anything, so I don't know if there's any questions at the minute.
Not right now, I don't think.
Okay, fine. Can people write it in the chat? Does anybody know?
Yeah, they can write in the chat.
Okay. And if anyone's got any questions, you write in the chat. So section 3, what we're going to talk about is performant A/B testing in a static site environment. Again, we're kind of solving the problem of how do we keep this website static, but also allow us to do these dynamic changes of A/B tests. So what is an A/B test? So an A/B test is where we show different versions of a website to a set amount of people. So 50% could see a header at this size, 50% could see a header at font size 12. It's an important part of our website optimization. We like to try out different changes to our website and actually have tangible metrics that we can use to base UX decisions on. It can be challenging in the static world because we need to make sure we're avoiding 2 things: slowing the page load. As I mentioned, these quick page loads makes us appear in Google above our competitors. We need to avoid introducing CLS. So CLS is community layout shift, and it's one of the core web vitals that Google uses to rank websites on. It basically means if there's any shift in the layout when somebody's viewing your web page. It's really good because it gets rid of web pages moving around, and it reduces that annoyance that people have when browsing the internet as well. And Cloudflare workers are what we use to run these A/B tests. They're serverless functions that are run on the edge of the network. I think they're running in Lambdas on Cloudflare. I'm not sure, to be honest. And these allow us to manipulate the site before it loads, because a user will send the request to the website. It'll hit this edge function. It'll do the manipulation, and then it'll continue to the cache or the origin server and then respond. So what do we actually do in this request chain? So during the test, we run each page request through a Cloudflare worker. So on every single post, we'll go and direct that request through a Cloudflare worker. The user is randomly assigned a bucket on the edge of the network. So they're randomly assigned this bucket in the actual Cloudflare worker itself. So the user's request not actually hit the origin server yet. We then place a cookie, still not hit or started loading the website. And we also test whether we would need to start rewriting HTML. And because we use Google Optimize to monitor what metrics are performing better or what buckets performing better, we set the variant for Google Optimize. And because we've set this cookie, the next time a user returns to the website, we read the cookie in the Cloudflare worker, and they'll be sent the exact same version of the web page that they had the last time they came. So an example, one of the tests that we did recently was testing the style of these in-article links. We wanted to know whether having a bigger underline had increased the clicks through to another page. Because one of our biggest challenges is to try and get more pages per session. So we put 50% of the audience, they all saw the original website with the smaller underline, and we put 50% of the audience into bucket A, which got a version of the website with a bigger underline. And when the user goes into bucket A, we use something called a Cloudflare HTML rewriter. This is a really good tool because it allows you to manipulate the HTML while it's actually being rendered onto page. It doesn't even wait for the HTML to download and then you manipulate it. It'll use HTML streaming to stream the HTML through your manipulations and then serve it onto the web page. So you get hardly any delay for this A/B test. And the benefits. So we can add and remove scripts that need to load early. If you want to test scripts that need to load in the head section of the web page, we can add or remove those scripts rather than waiting for JavaScript to load and then load in those scripts. Again, without waiting for client-side JavaScript to load, we can alter the CSS. So this is reducing cumulative layout shift. If you imagine traditionally, a page will load, the A/B test JavaScript will load, and then that CSS change will happen. So you could, in theory, see like the original layout of the website, and then the tested layout of the website, and you don't want to have that CSS, that CLS shift. And the pages all remain static. Because we don't do any dynamic changes on the client side, this page is still static. We've changed the HTML before it actually gets loaded into a user's browser. And this whole process all happens in about 0.4 milliseconds, which is crazy. So you're not adding any response time onto page load. And a user just won't notice that anything's happened. So that's it. So come to the end of the presentation. So to summarize, static sites allow us to build high performance websites. So they are a good thing. Static sites are making these HTML files that get served really, really fast. By using a network cache and response headers, we reduce the response time of these API calls, and we reduce server load. So we can in turn improve performance and also reduce hosting costs, etc. And we can also really pinpoint what needs revalidating. This allows us to keep performance while also allowing content that changes quite frequently. And like I just mentioned, utilizing Cloudflare workers, or should I say similar like Edge network workers, and the HTML rewriter, we can run these A/B tests without any shift on the front end. And these pages will still be static, we'll keep the performance, and we'll allow to run these tests and find out and optimize the layout of the website. Thank you. Any questions?
I don't see anything in the chat, Rob, just in case you can't see it. But I'm happy to give it a minute just in case anyone's writing or wants to jump in. I've
got one, but it's more because I'm not a techie person. But obviously I hear the word client side a lot. And what does that mean?
I think you're on mute.
Yeah.
No, I could hear.
Oh, my bad.
What was the question? Sorry, it's a bit muffled.
What does client side actually mean?
So we have our servers in the world, in the infrastructure. And these are the computers that are that websites are basically loaded on. Like I'm trying to explain it. Yeah, so the websites are all stored on these servers around the world, and server-side rendering is when the page gets generated and data gets fetched on these servers that are not located in your actual device. They're not on your phone, they're not on your laptop, whatever. Client-side data fetching all happens via your mobile phone. So your mobile phone will actually request the data and then pull it back onto the web page.
Thank you.
This is why Googlebot can't read them, because Googlebot doesn't have a way of triggering that data fetching and fetching it back to itself. It's getting better, but it can't do it yet very well. And SEO is one of our biggest challenges, as you can imagine. We're always chasing Google's algorithm changes. One small tweak on Google's algorithm, this is going on a tangent, but Google algorithm could change one day and our traffic could drop by like 25%, or vice versa. It could change one day and it goes up by 50%. It's just a game of cat and mouse all the time.
Cool. I don't think anyone else is got any other questions. But yeah, thank you, Rob, for taking the time out and speaking. Really unique subject. I'm sure we all appreciate it. Well, I definitely do, as well as Caitlin and Fraser. Hopefully everyone else does. But yeah, if I guess if anyone had anything to follow up, they can reach you via LinkedIn or pop you a message.
Yeah, definitely. I'm always happy to talk about rendering. It's just such a big deal for us trying to keep things so fast. And again, it's just chasing these core web vitals that Google have and trying to make your website load as fast as possible. If, say, one of our main competitors is IGN, if they post something and their website is loading like 100 milliseconds faster than our website, then their article on the same topic will appear above ours in Google ranking, and people always go for the first one. If you're down below past like 5 or 6, then you've got no chance.
Perfect. But yeah, thanks again, Rob. I guess just to the audience, thanks again for coming. This is our 3rd meetup. We're going to be looking to organize our 4th, immediately. I guess the main goal for us is to expand within the community, and get our name out there, as well as combining everyone together in one sort of room, discussing one specific subject. But yeah, if you can spread the words, share this with colleagues, friends, and then just keep an eye on for the next one. But yeah, thanks, Rob. We'll let you enjoy.
This is recorded, right, isn't it? So we'll have a copy afterwards.
Absolutely. Yeah, I will send it across to you, and we'll do a follow-up on LinkedIn as well, with any details if anyone else wants to get a hold of the recording. But yeah, thanks again, Rob.
Yeah, I'm happy to send my presentation out as well if anybody wants to have a look through it.
Perfect. Yeah, we'll add that to the post tomorrow. So then everyone else, if people weren't able to attend tonight, they can obviously view that at a later date. But yeah, appreciate your time. Thanks for hosting, and I'm sure we'll catch up soon.
Thanks,
No
Rob.
problem. Thanks.
Thanks, Rob.
Bye, everyone.